Okay, so here is kind of a more complex problem. So we're going to work this one out here together. All right, so um, this question here is asking me, what is the mass of CuHS2 would you need to make a 0.200 mole per liter solution with a volume of 500 milliliters? All right, well, is this even a dilution question? I need to be asking myself. Let's see. So here we go. What do I have? I have 0.200 moles per liter. That is a concentration. I have a volume of 500 milliliters. Again, that's a volume. And the question is asking me for a mass. Well, can I use this formula? The question is no, or the answer is no. Because I don't have 3 out of the 4 variables that are there. So that's not going to work for me. So what I'm going to end up doing actually for this particular question is I'm going to end up using, like in our last lesson, is I'm going to end up using these two formulas here in order to answer this particular question. So what I'm going to have to do is I'm going to have to use the formula C equals N over V in order to figure out N. And then I'm going to have to use N equals M over M, okay, in order to figure out my mass. So that means that I need to figure out the molar mass of CuHS2. Okay, so here's what I'm going to do is I'm going to do that first, actually. So I have 1 copper, and my copper there is 63.55 grams per mole. I'm getting that from my periodic table. I've copied and pasted some pieces of that there. Okay, then I have 2 hydrogens. Remember that this multiplies in to both. Okay, so 2 hydrogens, so that's going to be 2 times 1.01. Okay, and that's right here. Okay, 1.01 grams per mole. And then I have 2 times the sulfurs, so 2 times, and my sulfurs right here at 32.07. Okay, so let's put this all in our calculator here. So we've got 63.55 plus, well, 2 times 1.01 plus, oh, sorry, I didn't make that clear. So 63.55 plus, there we go, 2 times 1.01 plus 2 times 32.07. All right, enter. Oh, where did I do there? Enter. Oh, delete. There we go, enter. All right, 129. Need to think to myself, does that make sense? And yes, it does. 2 times 30, that's like 60, 60, 60. It's 120 plus some change. So is equal to 129.71 grams per mole. All right, so now I need to figure out N. So I'm going to use the formula C equals N over V. I'm going to rearrange this. Oh, hold on, let me. C equals N over, oh, sorry about that. Here we go. N over V. Okay, I'm going to rearrange this so that I'm going to isolate N. So I see here that N is equal to C times V. So my concentration up here, oh, okay, well now I have an issue, right? Liters and milliliters, that's not going to work. So I need to times this one by 0.001. Okay, so 500 times 0.001 gives me the value of 0.5 liters. Okay, so 0.5 liters times 0.2, so equals 0.2 moles per liter times 0.5 liters. Let's see how many moles we get. So 0.5 times 0.2 is 0.1 moles. Let's just double check that. 0.2, 0.5, perfect. So now I'm going to use N. So N equals M over M. Again, rearrange this. I'm trying to solve for mass. So mass equals the number of moles times the molar mass. So in this case, it's 0.1 moles times 129.71 grams per mole. Moles would cancel out. I'd be left with grams. That makes sense to me for a mass. So what I'm going to do here, mass is equal to that 0.1 times, and in my calculator, here I can go up until I select this number here, enter, press enter again. There I get 12. So 12.971 grams. Now I need to look up and see how many significant figures I can use. So I go back to the top of the question. Here I've got 3. Here I've got 3. So I can only report to 3 significant digits. So 1, 2, 3. This rounds up. So it actually is going to end up being 13.0 grams. There we go. All right, well, thank you very much for paying attention and following along with this particular solution. Remember that these are the sorts of questions that we're going to end up asking, and we're really going to have to decipher which sort of equations we're going to have to use. All right, thank you very much.